Hey, I'm Max, I'm a game developer, and today I will show you some ways games can try to prevent hacking on a local level, and some counters that hackers can use to still manage to do it even with the anti-cheat present. If you don't know much about how game hacks work, and you want to learn more, you can check out my previous video on that, link in the description. The best way to prevent hacks is by making the calculations and keeping the values on your server so a user cannot modify them. But you cannot always do this because it will be too heavy for the server and also create a delay in your game. Also, if your game is single player but has leaderboards, then there's no servers, but you still want to prevent hacking as much as possible. To do this, you will need to have some checks in your game that verify if the variables keep the values they should, and also check if your instructions are being executed. Of course, they can all be bypassed, but at least it will be harder. It is like a cat and mouse game where game developers and hackers try to get around each other. The sad part is the more things you add to prevent cheating, the more resource your game will take, so the more laggy it will be. Also, those are just some ideas that I quickly came up with to show the idea, but of course there are better ways to do it. Okay, so let's get right into it. The setup I have right here is a simple game I made that when you click increase it goes up and decrease it goes down for each one of them, and each one of them has a different protection. So let's load up my 2D test in Cheat Engine. First I will scan for 0, then I will hit increase, scan for 1, increase, scan for 2, increase, increase. Oh, it seems there's 2 of them. That's strange. Let's try to set this one to 15, see what it does. Okay, so it's this one. So you can see this one has no protection. If I set it to 99, it works fine. Here's the code for that first one in Unity. You can see I simply have a public int value, and when I hit the plus, it goes up. When I hit minus, it goes down, and it updates the text every frame. And I simply did this so when I change the value in Cheat Engine, it appears automatically. So this one has no protection. You can see, just like in the previous video, it's very easy to just go and change the values. Now let's try to find the second one, the box. So here I will search for 1, increase, search for 2, and you can see I found it right here. I'll go once just to make sure, yep. And if I change it to 99, you can see just like the other one, it works fine. So what is the protection I put for the box? It is simply by putting the integer value in another class, and this actually does not prevent finding the variable or does not make it harder. However, the difference is that in the first one, if I browse the memory region, I display 4-byte decimal, you can see I am inside of the class, so if I had other values, I could find them right here. But if I browse the other one, browse this memory region, you can see I am sort of in the middle of nowhere. So my 102 is here, but you can see around here, it's not the same thing as the other one. And this is simply because it created another class, so the 102 is not actually in the value right here, it's in the point. This value right here is a pointer, and the value is in another class. So this might help prevent a little bit finding constant values by browsing around the values you find, but probably not that much. Let's look at the third one, this one right here. I'll scan for 0, then I'll scan for 1, I'll scan for 2, and I didn't find it. So what is the protection on this one if I cannot find it? It is a crypted integer. Well, it's not really crypted, I just couldn't find a good word for it, but I guess it's kind of crypted. So what I did in this one is simply invert it and remove 15. It's kind of random, but this way, if my value is 0, it will actually be minus 15, and if it's 10, then it will be 10 times minus 1, so minus 10, minus 15, then minus 25. So since 10 is turned into minus 25, and technically 11 would be minus 26, then it goes down when you go up. So it will be very hard to find, but if you know what it does right here, if you know this math, then it is very easy to find. So let's say my generator right now is level 2, so times minus 1 it will be minus 2, and then minus 15 it will be minus 17. So if I do a new scan for minus 17, then I increase it, and I know it will actually decrease it. So I search for the new one, and there you go, I found it. And the reason why this number is so big here is because in memory, negative integers are displayed from 2 billion to 4 billion something. So you can see here, if I change the 8 to a 7, it should go up, and there you go, it did. So using crypted integers like this will make it harder to find, but once you find it, you can change it to whatever you want, and it will work. And in case you're wondering, it's also possible to find it without knowing the math, but it can be a lot harder. So I can start with unknown initial value, then do a first scan, then I will increase it, and here probably the first time you try you would do increase value, but then you might try decrease value, see what it does. Then you do it again, decrease value, decrease value, decrease value, then you can do increase value while going down, increase value while going down again, and then you can do unchanged value, and there you go, I found it again. Let's move on to the next one, the satellite right here. This one is actually pretty surprising. So this one you can actually find it really easily if I just search for 0, then 3, then 5, you know, there's nothing hiding it, so it's right here. But if I change it to something else, let's say 99, you can see what it does. Uh-oh, it detected it. So this one doesn't actually hide it, but it detects when you change it. Of course, there's a way to work around it if you know how it works, but it will be a lot harder to change without getting detected. Because now I'm wondering, how do they know that I changed it, and how do I bypass it? Is it another variable? Is it something in the code? I'm not sure. Okay, in this case I made it, so I know this is the one right here. It's simply using a double int. So it has two int values, and the second one is the copy of the first one, minus 1500. And then when I change the value, I check if it is 1 minus the second one is equal to 1500. If it is, then I increase and it's fine. But if it's not, then I will return true, and this is what trips my hacker bull right here. So obviously in this case, the user will know that they have been detected because of the text, but you could do it secretly or simply do something like if it detects a variable changing, then you automatically ban the hacker or you delete the save file. So this one is kind of for finding them, but without preventing them. To find the other one, just do 99 minus 1500, or you can simply browse this memory region, and it is the one right next to it. So this one is negative, of course, because it is in the 4 billion. So if I change this one to 1500, the other one should be 0. And now you can see it works again. Now let's take a look at the astronaut. This one is a bit strange too. So this one actually focused on preventing the change of operations. So if I scan for it, it's pretty easy to find. There's nothing preventing it. There you go. Now if I change it to 20, you can see it works and it doesn't detect it or anything. But of course I could combine all of these, which is what I did with the last one. So this one I actually tried to prevent finding out what writes to this address. And let's say I want to do increase. You can see when I click increase, the count here goes up. So it detects that this address of the instruction is what increases my variable right here. So if I show in this assembler, you can see right here increase EAX, which means increase this value when I click this button. So now let's say I want to remove this code. I replace it with nothing, and now when I click increase, uh-oh, it detected it. So you could do this, for example, with the health variable. When you get a damage, it reduces your health, and it can be pretty easy to just remove the instruction that removes the health. So now you're invincible, but you could detect that. So if I restart my game again, I can find my variable again, and this time I can show you that it's actually possible to bypass this as well, but you have to sort of know how it works. As you can see, it is actually not that complicated. I simply increase the value just like the other one, but I keep the old value in another int, and then I check if it actually increased it. So if it's the same or lower, then that means it didn't increase it, so it triggers it as true. So once again, just like all the other ones, this can actually be bypassed if you remove the if here. So let's say I detect again the instruction that increases my count. So right here, this increases my count. I show in this assembler. Now you can see here the increase EAX, that increases my counts, and here, just right under, you can see it compares it with another one, which is ECX right here. And then, based on that result, it jumps short if greater. So we simply have to change this to jump short if lower or equal, less or equal, and then I can remove the increase, and I can do it without increasing, without triggering the text. You could also probably just remove the instruction inside right here since there's just one, but if there's a lot, you're probably just better off just removing the jump. But here, if I replace this with code that does nothing, which is the one inside the jump, I think this would also work, and there you go, it does. So using just simple methods like this, you can make it harder to change instructions in your game. Finally, I made the ultimate variable that is very hard to change right here. It combines random crypted int. Some of them are inverted, which means they will do times -1, and some are not. And also I have a custom add offset that in this case I set to a set number so I could find it easily. But you can make it random and that will make it even harder to find. And here are the functions if you're interested. And I also have a double crypted int, which is like the double int of the satellite, but with crypted int instead. And then I use it in my increase and display. So doing this, it's actually really hard to find. You can see I can search the values, and of course I will not find it because it is crypted. So there you go, I don't find it. And even if I search for increase or decrease, I will not find both because there are double ints also. I will not find both because one is inverted and the other one is not. So the only way I can really kind of find it is if I search for unknown value and then change the value. After changing it, of course, change value, change value, change value, then unchange value and click another one or anywhere. After doing a few unchange, I can do changed again, search for change, change, change. I can also go unchange, increase and decrease because I know now it's back at what it was. And I have now 32 results. So now I'm down to 6 results. And I know because I did the code that it is these two because they're barely in the negative because they're 4 billion and these ones are actually really high numbers, so I don't think they are the right ones. And this one combines pretty much everything from the other ones and even more. And also, of course, if I try to change one of the values, even just slightly, it will detect it. If I change it back, then it should work. There you go. So this is sort of like the ultimate anti-cheat int, but you could say that this increases a lot the performance since you have to decrypt and recrypt your value every time, and you have 2 ints for each int. So definitely don't do this for values that you will use a lot, but for the important ones you definitely could. So those were the ideas I had to prevent cheating in the game. Hopefully you enjoyed watching this and maybe that gave you some ideas to help protect your game if you want to.